Thanks for that introduction. It's a real pleasure to be here today with you at Trino Summit. Today, I want to talk about virtual view hierarchies. And these are for fun, for prototyping, and for extending apps to use Iceberg. The last one there being probably the most exciting use case that we've found for this concept. I'm Rob Dickinson. I'm VP of Engineering at Graylog. I'm easy to find online. And Graylog is a security company, and our data architecture is based on Trino. So we've been using Trino for a number of years now, embedding Trino in our solutions. And then this idea here of virtual views and hierarchies of virtual views is one of these ideas that's really central to the work that we're doing. All right, so before we jump into what virtual views are and hierarchies of virtual views and some of these other ideas, let's make sure we at least have a basic concept of what we mean when we're talking about SQL views. So the basic idea here is that we're creating a view as step one. That view defines a select statement, essentially, and then we're able to use that view. So in this case, we're creating this view called my view, and then we're able to select data out of that my view. We're also able to add additional criteria in the where clause there if we want to when we go to use that view. So there's some classic use cases for when you'd want to use SQL views, things like hiding joins, hiding complexity. There can be a lot of complexity that gets buried in that select statement that you don't have to deal with all the time. You can reuse that definition. You can add computed columns, so you can put extra columns in the select statement here. And then you can also hide sensitive columns, or you can hide sensitive rows. You can leave columns out of the select statement, or you can specify a foundational where clause that really can't be taken out later in order to hide either columns or rows. You can also cache query results if this is a materialized view. And yeah, like you, I'm maybe starting to nod off here a little bit. This is all the classical stuff that you'd see in the Trino documentation. This typically are the kinds of use cases that we think about when we think about views. Views are very much kind of the icing on the cake, if you will, the icing on our physical schema to make our physical schema a little bit easier to use. This is kind of a yawner, right? Now, I think there's an entirely new way, maybe not entirely new, but there's definitely a more exciting way to think about views that I call virtual views. Maybe there's a better word for this or better term for this, but to kind of disambiguate, get the conversation going here. We've got those logical views. Those are the cases that we saw, most of them so far, those classical cases, hiding complexity, redacting columns, adding computed columns, those kinds of things. We know we've got materialized views. Those are really helpful for caching, for performance. It's basically a view that acts like a table, that it gets updated automatically on the back end. Very cool for the connectors that support that concept. But I think there's another concept that is really helpful when you start to look at this from an application perspective. And that's what I'm calling here as being virtual views. And these views, yeah, the key idea here is that these are detached from the physical schemas entirely. These views are really organized by the application or by the feature within the application. So being separated from the physical schemas, from the physical connectors that are being used. We can take those views, we can layer them into hierarchies. We can build views on top of views on top of views, which is very, very helpful because when we layer into a hierarchy, we can then go back and swap out any of those layers that we want. Those layers are reconfigurable. They can be dynamically generated. They can be programmatically generated. This whole idea then of building views for your applications, for your features, independent of the physical schemas and working backwards from that ends up being really, really useful for prototyping. And then also when it comes to taking an existing application and extending it to use something like Iceberg storage, this ends up being a really helpful concept. So that's kind of the theory. So let me give you a very concrete set of examples here that'll kind of show you how we saw this concept playing out in our data architectures. So the key concept here with virtual views is that we're virtualizing those data sources. So we want to hide our data sources by using these views and using these views creatively. So let's pretend that I'm building an application and I'm going to prototype this application. And that's the My App application. And I want to keep this really simple from the application perspective. I want to be able to go and query some log data. So what I want to do from the client perspective here is I want to be able to say select star from logs, and I'm going to have an object, a catalog on the back end in Trino that is going to provide that data for this application. And we just made this up here that it's a My App catalog because again we want these virtual views to reflect the application, not the physical infrastructure. Then what I'm going to do is I'm going to say this logs view, then instead of defining that as a table, as something physically concrete like that, I'm going to define my app.data.logs as a view. And that's the concept that I'm going to use from the application perspective because I'm virtualizing away that data source. It then becomes very easy to prototype those data sources. I can even do this using static values. So I don't have to even use a database yet. Trino has this wonderful capability. You can define views that basically have static result sets embedded in them. In this case, this is a key value looking data set that has 3 rows each, 1, 2, and 3. And now that I'm putting that data into this virtual view, from my application perspective, it's querying it as though it was coming from a real database. It doesn't really know the difference. So it's very easy to build prototype data this way. We did a lot with a memory connector in our early days this way, but we hid the use of the memory connector through a virtual view like this so that the application really wasn't aware of it. The only tricky thing about this concept is really right here in the yellow part. Even though we're saying this is a view that uses static data, it's not actually using data that comes from any particular database, from any particular connector yet. We still have to actually store that view in a connector. So there's kind of 2 ways that we can think about that. One is if you know you're already going to end up on Iceberg, or you have another canonical store that you're using, obviously just put your views onto that connector. But again, you want to do it in an application-centric way versus a physical schema sense. If you don't want to use any other databases at all, it's actually very easy to create a connector that all it does is store view definitions. And I did one of these. I called it View Zoo, just because the name is super fun. We'll come back and talk about that. But basically, this is the only really sticky bit when you talk about these views that are kind of independent of any data source or potentially cross multiple data sources, is where to actually store them in the end. Use Iceberg or use something that you've already got. That's kind of a no-brainer. If you want something that's independent, you can use something like ViewZoo. We'll come back to this. All right, so now the next step in our journey, we've built this application. We've got these static data sets. We can do queries and joins and all those things against them. Now we want to say, let's replace those static data sets with some real data coming from a real connector. And so what we're going to do now is we're still in this My App catalog. So it's still an application-centric approach here. We just remap this now. So instead of this returning that static data set that we had before, now we're actually going to Postgres, in this case, to a particular physical schema. We're even picking up versioning at this layer now. So from the application perspective, the application is just saying, give me the latest version of the thing, and we'll do the version mapping under the hood in terms of the columns that are provided. That's a pretty cool idea, right? But what's really exciting about this is we're insulating our application from these changes underneath the hood, including where the data is being provided and whether that data is real data or fake data or whatever. Now we start to think about, well, let's take that and let's have an option to extend that to Iceberg. So maybe we've got our short-term data is living on Postgres. Our long-term data is going to live on Iceberg. We're periodically going to replicate that data from Postgres to Iceberg. Well, guess what? We can hide that entire concept here through the virtualized views that we've already established. So in this case, what we're going to do, and again, this is admittedly a simplification for a reasonably short talk, but what we're doing here is we're taking that same logs view, and now we're redefining it as a union between the short-term data that we have in Postgres and the long-term data that we have in Iceberg. Again, a little bit of simplification here, but you get the idea. A view in Trino can cross multiple data sources. It can do these complex joins or unions and still get good performance when we end up applying another where clause on top of this. So this kind of pattern ends up being really, really convenient in terms of plugging Iceberg into existing applications. What you basically want to do is you want to take your physical schemas that you're probably using now, virtualize those, and then provide the ability to hybridize that between what you had before and then the data that you're replicating over to Iceberg. Now, you don't have to stop there, though. You can then take this pattern and you can layer it like stacks on a cake. And all of this starts to get really, really exciting because all these changes that we're talking about making here, these are all changes that just show up magically to the application. The SQL never had to change. The applications didn't have to be rewritten to take advantage of this new Iceberg-powered architecture. But let's talk about how we stack these up now. So now we can define what we call a view hierarchy, where these views depend on other views, where each of these layers in the chain are now swappable. So we might start off with a top layer here. This is the top point. That's the entry point for our queries. Maybe this is where we add some computed fields. Maybe we do a little bit of version mapping here at the very, very tippy top. Then maybe that depends on another layer underneath where we provide a system-wide where clause for privacy protection, for example, a one-stop shop to redact all the data coming through the logging here. And then at the bottom of the stack, for example, we might have the merging layer where we have that union all between Postgres and Iceberg. That's where our ingestion engine is coming in and doing updates. And guess what? Each of those actors that we talked about can change these layers independently, because that's something that you can do in Trino. So this ends up being incredibly powerful. Maybe even at runtime, I can switch between having configurations that are Postgres only and then configurations that are Postgres and Iceberg. And I can programmatically create this layer at runtime based on the kind of configuration that I want. And I don't have to change any of these other layers as I do that. This is really the power that you start to get into with virtual views and virtual view hierarchies. I'm also just showing one stack here. Because these are application specific or even feature specific, I can build as many of these hierarchies as I want without it really costing me anything in terms of the underlying infrastructure. Trino almost completely supports this concept out of the box. Trino views can span more than one connector. You can pull in data from multiple sources at once. You can also use no data sources and just use predefined result sets. Trino also completely supports this idea that parent views can be replaced with new definitions without breaking those dependent child views downstream. You do have to be very careful not to break your data types. So you may have to be more explicit in your data types in your base views than you might otherwise. You don't want to necessarily inherit Iceberg data types at that layer if you're really trying to do something that's portable. But that little caveat aside with data types, views are very easily replaceable. As we talked about before, the only really sticky bit is where to keep these things. If they can span more than one connector, or they might not even be associated with any connectors at all, you still have to make a decision with Trino about where you're going to store them. So if you're going to end up on Iceberg, or you already know that there's a common connector that's really going to be there all the time, then definitely go with that. If you want a completely independent way of doing that, again, it's not difficult to do. by creating your own connector to do that. I did an example of this just to show that it's not very difficult to do. So I did this connector called ViewZoo, and basically all it does is it stores logical views directly on the coordinator file system. And it reads and writes essentially JSON files to a local directory on the coordinator. You don't need an external database. You don't need an external object store. It does not support materialized views. That's the one important caveat, at least not the current version. But this is a very lightweight thing to do if you're not ready to jump into Iceberg yet, but you want to provide the flexibility to do something like that in the future. You can certainly define your own connector or use this or something like it. Thank you so much. We're Graylog API security built on Trino, and would love to keep the conversation going. Thanks for having me.